Today we're going to graph the other trig functions, and when I say that, we're going to just take a look at it mostly, and then when we get to the homework, not so worried about the graphs as I am the information. So the first thing we're going to do is we're going to talk about the graph of tangent. And so let's just do y equals tangent of theta, or x. And one of the big things that I want you to notice is that for tangent and cotangent, the period is pi. And it tells us that at every pi over 2, so let me just draw in, I'm going to make a couple of cycles here. Anywhere where it has pi over 2, so negative pi over 2, pi over 2, 3 pi over 2, that gives us an asymptote. And unlike the other ones, if you graph y equals tangent of x in your calculator and then do zoom trig, you're going to see that the graph goes like this, and it should go through 0, 0, pi 0, and then it's sort of curve upward. And that's the graph of y equals tangent of theta. For y equals cotangent of theta, like I said, that the period is still pi. So pi over 2, and 3 pi over 2, and negative pi over 2, negative pi. This time, the asymptotes are at the whole number pi. So those yellow lines shouldn't be crossed. And for cotangent, this time the graph goes downward. And so this is what cotangent would look like if we just asked what does y equal cotangent look like. For for y equals cosecant, remember that's the same thing as 1 over sine. The period is still 2 pi. And let me show you how I think about this graph. If I graph y equals sine of x, which I'll do in orangish color, we should all remember that the graph looks like this. So when I graph y equals cosecant of x, where I used to be at 0, here I'll use green for my asymptotes, where I used to be at 0 is now where I'm going to have my asymptotes. And here was the top, which I'm still at the top, or actually I'm now going to have a relative minimum there. But this point at 1 is still at 1, and I go up from here. This point at the bottom is going down from there. So the green one is the cosecant graph. So what would the graph look for secant? When I have y equals secant x, which is 1 over cosine, the period is still going to be 2 pi. So here's 0, here's 2 pi, here's pi, 3 pi over 2, and pi over 2. And if I were to graph cosine, it starts at the maximum goes to the bottom, comes back up. So there's my graph. Now, the asymptotes will be where I used to be at 0, which is at pi over 2 and at 3 pi over 2. And so here's one where I'm at the maximum, and here's another one where I'm at the maximum, and from there I'm going to graph up again. And here where I'm at the bottom, the curve goes down. So basically I use my cosine graph to graph the secant graph. Like I said, I'm not so worried about the graphs as I am the questions that we have in example number 1 through 5 over here. So in example number 1, we have the tangent of 7 pi over 2. I'm going to go back and look at my tangent graph to see if that can help me. So here's the tangent graph. Anywhere I see pi over 2, I basically see something that doesn't exist, which means that the tangent of 7 pi over 2 is going to be undefined. If I'm looking for the cotangent of 3 pi over 2, let's take a look for that one. Here's my cotangent graph. And anywhere I'm at pi over 2, the y value is 0. So my answer for the cotangent of 3 pi over 2 is 0. Alright, let's try example number 2. Where it asks, where is the cosecant of theta equal to negative 1? Well, let's go back to the cosecant graph. Alright, I'm looking for where the cosecant is equal to negative 1. So here's negative 1. The x value is 3 pi over 2. So my answer is theta equals 3 pi over 2. But that's not my only answer because the period is 2 pi. So this will come up every 2 pi as an answer. When I'm looking for the secant of theta equals 1, I go back to the secant graph, and I'm looking for the secant graph equaling 1. Well, that happens right there, and that happens right there. So it happened at 0, and it happened at 2 pi, and it'll happen again at 4 pi. So my answer for this one is 0 plus 2 pi n, where n is an integer. And I can use these graphs to kind of get all of these done. So we're given a problem that says y equals the cosecant of theta, sorry, not cosecant of theta, cosecant of 2 theta minus pi over 2 plus 1. So the period is still equal to 2 pi over k for a cosecant, which in this case is 2 pi over 2, which is equal to pi. The phase shift, we're going to do the same thing we did before. 2 pi minus pi over 2 equals 0. 2 theta equals pi over 2. And then when you divide it by 2, in my calculator I'm going to do 1/2 divided by 2, which equals 1/4, which means this answer is pi over 4. And my vertical shift, you should know, is equal to 1 because that's the last answer. Before we go on to example number 4, I'm going to do this exact same problem with tangent of 2 theta minus pi over 2 because there's only one slight difference. The only difference is the period. For tangent and cotangent, so all the other answers are going to be the same, but for tangent and cotangent, we're going to use pi over k instead of 2 pi over k. So if the problem said tangent, my period would be pi over 2 because k is equal to 2. and the other two answers would have stayed the same. So the only difference between these problems in example number 3 is if we use tangent or cotangent, then it's pi over k instead of 2 pi over k. For example number 4, they give me the secant. They give me a period of 3 pi, and they give me a phase shift of pi over 2, and they give me a vertical shift of 3. I'm going to do example number 4 in two different ways again. First one with secant, and then I'll do it again with cotangent, just so that we can see the difference. So we got the secant, y equals the secant of something plus 3. So 2 pi over k equals 3 pi, which means 2 pi is equal to 3 pi k, which means divide both sides by 3 pi, and k is equal to 2/3. I'm going to take this pi over 2 and plug it right there and see what happens. So 2/3 times pi over 2 plus c equals 0. When I multiply 2/3 times 1/2 in my calculator, I get 1/3 pi plus c equals 0. So c equals negative 1/3 pi when I subtract it to the other side. So let's do the same problem with tangent and 3 pi, and pi over 2 is the phase shift, so period, phase shift, and the vertical shift can stay at 3. So 2 pi is not what we're using. Pi over k equals 3 pi, which means pi equals 3 pi k when I multiply both sides by k, divided by 3 pi, and k is equal to 1/3 theta. I'm going to take this pi over 2 and plug it in here now, and that's going to give me a different c than I had for the last problem. So 1/3 times 1/2 is 1/6, plus c equals 0, so c equals negative pi over 6, which goes right in there. Lastly, we're given this word problem. Go ahead and pause this while you read it. And so its first question is find the location after 15 seconds, which means I'm going to plug in t equals 15. Remember to make your, so here's the light, make sure your calculator is on radians. And so this is shading 11 feet down the road. When I plug in t equals 25, the answer is error. So what's happening? Here's my rotating light. Where does it hit? It says error in my calculator because the light is facing straight that way. So if the light is facing straight that way, when is it going to hit the driveway? The answer is it's not. And so that's what we got for example number 5b, and why we got a error in our calculator. Please email me any questions and start working on your homework.